Alright guys, so here's the test review that I promised. So this number one, it's pretty simple when you understand what's going on. The question is, which point is a reasonable solution for the following system of inequalities? So here is the system of inequalities. In order for one of these points to be reasonable, it has to satisfy all three inequalities. That means when I plug the point into the inequality as its y and its x, it's going to be a true statement for all three of them. So I'll show you the answer. The answer is C, and I'll show you why C is the right answer. Because if I plug C's coordinates in to this first, second, and third inequality, it's going to satisfy all three of them. So here we go. C says that x is -3 and y is -1. So let's go ahead and do this first one. So if y is -1, then I'm going to have -1 less than or equal to 1/3 times x. 1/3 times x is -3 plus 5. Well, 1/3 times -3 is -1. So really what I have is -1 is less than or equal to 4. And that's a true statement. -1 is less than or equal to 4. It's a lot less than 4, okay? So that's true. We know this one's right. Let's try out the second one. -1 is greater than or equal to -3 times 2, so 2 times -3, minus 2. And I know that that is -1 is greater than or equal to -8. -3 times 2 is -6, minus 2 is -8. So -1 is bigger than -8. So that's true. And let's check this last one. -1 greater than or equal to 8/3 times -3, which is -8, plus 5. That's going to simplify to -1 is greater than or equal to -3, which is also a true statement. Notice that this point satisfies all three of these inequalities. Therefore, it's the only solution. If you plug these into those inequalities, you'll find that they might satisfy one, maybe two, but they're not going to satisfy all three. And the only way that something can be a solution is if the coordinate satisfies all three of the inequalities. So let's go ahead and look at this next one. It says graph the inequality. Well, if I'm going to graph something, that's what I'm graphing. If I'm going to graph that, I need to solve for y. So I've got -4y greater than or equal to -3x plus 12. If you're confused about why I wrote it like that, all I did was I took that positive 3x and I moved it to the other side and made it negative. All right? Now the next step I'm going to do is divide by -4. Divide by -4, divide by -4, divide by -4. So after I do that, what's going to happen is I'm going to have a positive y. My sign's going to flip directions because I'm dividing by a negative. And then I'm going to have positive 3/4 x minus 3. So I've solved for y, now I can graph it. Let's check which one of these graphs is the right answer. I'm going to start at -3, so there's one graph that starts at -3. Here's another graph that starts at -3. So we know it's not B, we know it's not C. It could be D, could be A. My slope is going to be going up 3/4, up 3/4. So I'm going to go up 3/4. This is the only one that matches. Up 3/4. It's probably going to be A. Even still, it says that y is less than that, so I'm going to shade below. Surely my answer is A. Okay, let's go on to the next page. So I've got a problem that says a steel company produces two types of machine dies, part A and part B. The company makes a $4 profit on each part A, so we know it's $4 for part A, and $6 profit on each part B. Let X represent the number of part A. So if X is representing the number of part A produced in a week, well, I've got $4 for each part A, so $4, and then, $4 for each part A. X is representing how many part A's there are, so 4 times the number of A's we have being produced, and then plus 6 times Y is the number of B's we produce in a week, so 6 times the number of Y's that we have equals the total profit. So actually I've got two answers here that say the exact same thing. So A or C, they're both the exact same answer. Okay, so A, C. Not air conditioning, A or C is the right answer. All right. Excuse me. Next one, very similar to that previous one. We've got a dietitian needs to purchase food for patients. She can purchase an ounce of chicken. So 1 ounce of chicken costs 45 cents. And an ounce of potatoes costs 10 cents. Let X equal the number of ounces of chicken. So X represents the number of ounces of chicken. And then Y represents the number of ounces of potatoes. Well, how much does chicken cost? So for every ounce of chicken, X, I want to multiply it by 45 cents to find out how much the chicken's costing us total. And for every ounce of potatoes, Y, I want to multiply it by 10 cents, which is the cost of potatoes, to find my total cost. So my total cost, and for some reason it says P, maybe that's for price. My total price is going to be 45 cents for the ounces of chicken, however many ounces of chicken I have, and 10 cents for every ounce of potatoes that I have. All right, hold on, guys. Who's out there, Zach? All right, sorry about that. So here we go. We're trying to find the maximum and the minimum. Two things we're trying to find for, and that is going to be our optimizing equation. All right. So to find the maximum and the minimum, usually the maximum typically is going to be the far right corner. But ultimately, all we have to do is circle all of our vertices on our area of feasibility. All right, that's our region of feasibility right there. So we need to circle all those vertices and plug them into the equation. P equals 2, but instead of writing X, I'm going to go ahead and start writing these coordinates. So I've got 0 plus 6 times 8. That's going to equal 48. I've got P equals 2 times 9 plus 6 times 8. That's going to equal 66. I have P equals, let's do this one, 2 times 9 plus 6 times 3. So that's 18 plus 18, 36. I have P equals 2 times 0 plus 6 times 2. That's going to be equal to 12. And then lastly, I have P equals this last one, 2 times 2 plus 6 times 0 equals 4. So just to remind you guys, the reason we plug in the vertices are those are the furthest points. Those are the most extreme points on our area of feasibility. Area of feasibility is just the area in which all the solutions exist. Okay? So these are the furthest most points. Those are the extremes on the area of feasibility, which means that these points are either going to give us our biggest values or our smallest values. All right? So as you can see here, the point 2, 0 is going to give us our smallest value, and the point 9, 8 is going to give us our biggest value. So here's our biggest value, here's our smallest value. Notice our biggest values are typically to the upper rightmost, and our lowest values, our smallest ones, are typically bottom leftmost. All right? So our answer is the first one, maximum value of 66, minimum value of 4. Minimum value 4, max 66. All right, looking at number 6, it's just like the last one, except this time we're going to have to graph. We're going to have to graph our inequalities. So graph the inequalities and shade accordingly. So I'm going to start off by graphing x equals 0 right here. Anywhere along this line, x equals 0. It says it's bigger than that. So that means I'm shading somewhere to the right where the bigger x's are. Then x is less than 10. So that means somewhere in between here now, all right? So if it's less than 10 but bigger than 0, y is bigger than 0. So there's my 0 for y. Anywhere along that line, y equals 0. But y is less than 5. So here's the most y can be. So that means now I know we're somewhere in here. All right, we've got one more thing to graph. Let's graph this one. When I solve for y, before I can graph it, I have to solve for y. I'm going to have y is greater than or equal to negative 2 over 3x plus 2. Now, I didn't show you all the steps I took to solve for y. If you want to learn how to solve for y, you can look at one of my earlier videos, earlier on in the school year. Look at week 1 maybe. I'll probably have some solving for y videos there. So we have to solve for y before we can graph it, because we want to use our y equals mx plus b, or point slope formula, okay? So here's 2, so that's going to be our starting point, positive 2. When x equals 0, y is positive 2, and then I'm going to go down 2, right 3, down 2, right 3. So there's my last line. And it says that y is greater than that. So I'm shading up here. So anywhere in here are my possibilities. So my vertices, if I'm trying to find my maximum, I can plug all of these vertices, 1, 2, 3, 4, 5, all the vertices of my area of feasibility into this price equation, or this cost equation, okay? I'm trying to maximize my profit. Now, like I told you guys, I think in the last one, generally speaking, the one that's going to bring us the most profit is the point that's furthest right and up, okay? So this point is probably going to bring us the most profit. Let me explain it this way. This point right here is at 0, 5. This point is at 10, 5. And this point is at 10, 0. Now, if I put this in terms of, like, say, x equaled candy bars and y equaled Skittles, and I was selling these things, then if I sold 0 candy bars and 5 Skittles, I'm not going to make as much money as if I sold 10 candy bars and 5 Skittles. Or if I sold 10 candy bars and no Skittles, I'm not going to make as much money as if I sold 10 candy bars and 5 Skittles. In both cases, this point's bigger than the other two. That's why it's probably most likely my maximum. So let's go ahead and find out. If I plug this point into this equation, what I'm going to get is P equals 22 times 10 plus 18 times 5. So I've got P equals 220 plus 90, which is 310. So my final answer is 310. If we wanted to check that, we could take all of these vertices and plug them into this equation and see which one gives us the biggest number. But I figured I'd just take the shortcut and pick the top right one, just for the sake of time. All right, so this one says Valerie purchases X tubes of lipstick for $3 each, so 3 for every tube of lipstick, 3X. And then Y bottles of nail polish at $1 each, so plus, I can write 1Y or I can just write Y by itself. Both are the same thing. She spent less than $8. So there's my inequality, and then it says write an inequality and determine which point represents a reasonable number of lipstick and bottles of nail polish that Valerie purchased. My answer is C, because that's the only point that I can plug in here and actually satisfy this equation with. I think this one will get me 8, but 8 is not less than 8. 8 is equal to 8, all right? This is the only point that will get me something that's less than 8. So if I plug 1 in for X and 3 in for Y, I would have 3 plus 3 is less than 8, and 6 is surely less than 8. So that does work out. C is our answer. Let's look down here. Joseph works at a deli after school for $9.50 an hour and mows lawns on the weekend for $10 an hour. His parents will not allow him to work more than 13 hours per week, and he wants to make at least $150 a week. Which of the following systems of inequalities represents this problem? All right, so we don't know how many hours he works at the deli after school, and we don't know how many hours he works mowing lawns after school. So let's go ahead and use X and Y to represent that. So if X represents the number of hours he works at the deli, we've got $9.50 for every hour he works at the deli, plus $10 for every hour he mows a lawn. That has to be greater than or equal to 150, because he wants to make, says at least. So if he makes 150, he's satisfied, but if he makes more, that's even better. So he wants to make at least $150. So this has to total up to be more than $150. And then lastly, we have the number of hours he works at the deli plus the number of hours he spends mowing lawns. Well, his parents don't want him to work more than 13 hours a week, so it's got to be less than or equal to 13. If he works 13, that's fine. If he works less than 13, that's even better. Both the hours that he spends working at the deli and mowing lawns has to be less than 13. So our answer is going to be B. All right, last page, the tough one. A nutritionist was requested to devise, and this is straight up called linear programming. This is a lot of work to do, all right? But if you can do it, that's impressive, okay? You can impress some people with this type of knowledge. All right, here we go. A nutritionist was requested to devise a formula for an instant breakfast. The breakfast must contain at least, so it's got to contain at least 12 grams of protein and 8 grams of carbohydrates. A tablespoon of protein powder made of soybeans has 5 grams of protein and 2 grams of carbohydrates. A tablespoon of protein powder made from milk solids has 2 grams of protein and 4 grams of carbohydrates. Soybean powder costs 70 cents per tablespoon and milk protein costs 30 cents per tablespoon. Determine the number of tablespoons of each type of product needed to be used to have the instant breakfast meet the requirements and minimize cost. Okay, so the main thing we're looking for is we're trying to find the number of teaspoons of each of these types of product. All right, so one type of product is the soybean, the protein powder from soybeans, all right? So let's go ahead and define our variables. Let's say X equals number of tablespoons of, and I abbreviated, okay, tablespoons of, I'm just gonna say soybean powder, all right? And then Y is the number of tablespoons or teaspoons of milk solids. So again, we're trying to find out something that gives me a total of 12 grams of protein. So in my constraints, we need to have, oops, sorry, I wrote that the wrong way. We need to have at least, so 12 or more grams of protein, okay? Well, how much protein is in X, which is the number of soybean, or a tablespoon of soybeans? How much protein is in a tablespoon of soybeans? It says 5 grams of protein, so we've got 5X, so 5 grams of protein for every X I have. And then also, let's see, plus how many grams of protein are in the soy or the milk solids. That's 2 grams of protein right there. So 5 grams of protein is in the powder, or I'm sorry, the wait a second, I'm lost. Tablespoons of protein powder made of milk from milk duds has 2 grams. Okay, here we go. 5 grams of protein is in the powder made from soybeans, so that's 5X. 2 grams of protein is made from the milk solids. Sorry, I don't know why that took me so long. All right, 2Y. And then the other thing, so this is all protein. This top equation is all protein, or inequality is all protein. Next one is going to be all carbohydrates. So we need at least 8 grams of carbohydrates. We've got 4 grams in, or we've got 2 grams in the soybeans, so 2 for every tablespoon of soybeans we have. And then we've got 4 grams in the milk solids. So those are my constraints. I need to solve for Y before I graph them. So if I solve for Y, I would have something that looks like, I'll solve this first one and write it right there. I'll solve the second one and write it right here. So this looks like it would be Y is greater than or equal to negative 5 over 2x plus 6. And this one looks like it would be Y is greater than or equal to negative 1/2 x plus 2. So I'm going to go ahead and graph both of those equations. Plus 6, go down 5 over 2. There's one equation. Looks like I need to shade greater than that. My second equation, start at 2, go down 1 over 2. So down 1 over 2, down 1 over 2. Again, shade above that. Here's the place where they're overlapping, all this area. And my vertices, just for this area, are going to be right here, and right here. Not that one and not this one, because that's not actually in the shaded region. So here's the area of feasibility. My vertices have to be on the outside of that. So we've got a vertice of 0, 6. We have a vertice at 4, 0. And we have a vertice at 2, 1. Now if I plug those into my equation I never made my equation to be optimized, which is soybeans cost 70 cents. So 0.7 for however many soybeans I have. Remember, soybeans is X. And then 0.3 for every milk protein I have. So plus 0.3 for Y equals I. Now I'm going to plug that into those three equations, or these three vertices into that equation. So 0.7 times 0 plus 0.3 times 6 equals 1.8. And then I've got 0.7 times 4 plus 0.3 times 0. That's going to equal 2.8. And then I've got 2, so 0.7 times 2 plus 0.3 times 1. That's going to equal 1.7. So which one costs the least amount? So here we go. Minimize cost. This one costs the least amount. When I plug in my vertices, remember, those are the extremes. That's going to give me my minimums or my maxes. So my extreme is going to be 1.7. So my optimizing pair is 2, 1. So by buying 2 tablespoons of the soybean powder and 1 tablespoon of the milk solid powder, that's going to be my smallest price, which is going to cost me $1.7 pretty much. And that is how you do that problem. Alright guys, well, hopefully you review this before taking your test tomorrow. Good luck, and I will see you in class.